before we starting try how we can deterministically to determine some invariable structures, right? Invariant structures. So basically, you can anybody tell me how many numbers we are able to fill in, right? So is the number of the numbers to fill in. Can anybody tell me, is this deterministic or not? You can use the chat box, or you can just unmute yourself, okay? So can anybody tell me how many numbers we are going to fill in? How do we count how many numbers we are going to fill in?
11. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11.
11 numbers? Okay, I mean, including the number they give to you. Including the number they give to you. So how many numbers in total we are going to fill? Let's counting, okay? So when we do the counting of the geometry counting, okay, we can either counting by rows or counting by columns, okay? So let me give it slowly. Let me notating this is the first row, this is the second row, this is the third row, and this is the fourth row, okay? Anybody can counting how many cells on the first row?
2. 3.
3, yes. How many numbers on the second row?
The second
one. 4.
4. How many numbers on the third row?
4.
4. How many numbers in the last row?
3.
Okay, so can anybody help me to add this number together?
3 plus 4 plus 4 plus 3.
Wait, I think 9, 10, 14. 14.
Okay, so that means what? That means including the number they give to you, we totally need to fill in 14 numbers. Am I right?
No.
I mean, including the number they already give to you. We need to fill in the 14 number in total.
Yes.
And this 14 number, based on the game requirement, they are consecutive numbers. Am I right? Okay, so now next I want to introduce some counting problem. Okay, so can you tell me based on the number it gives to you, which is the smallest number?
3, 1.
No, 66.
Which is the smallest number?
66.
Okay, 66. Who can tell me which is the biggest number?
78.
78. Okay. Well, I mean, based on the number they give to you. This 3 numbers is deterministic, right? So you must know at least you must including this number, right? And you must including this number, right?
Yeah.
Okay, then here, so that what does that mean? So that means you must including 67, 68, 69 up to 77. Do you agree with me?
Yes.
Because you need consecutive, right? Okay, now next I want to teach you guys a little bit is how do we count number of numbers between in a range. Okay, let me make things very simple first. Okay, so who can tell me 1, 2, 3, 4, 5? Who can tell me how many numbers here? I write 1, 2, 3, 4, 5. How many numbers?
15.
Huh? No, I write 1, 2, 3, 4, 5, right? How many numbers I write? How many numbers I write?
15.
Okay, so if I starting with a different one, okay? If I write with 88, 89, 90 up to 92. Who can tell me how many numbers here?
5.
Okay. In order to counting this, okay, I want to introduce all of some concept. Okay, so these concepts are very simple, but it's always used. Okay, this is called the one-to-one correspondence. Let me explain this concept for you. Okay, so if I write 1, 2, 3, right? How many numbers I write? 3. Okay, if I write 88, 89, 90, how many numbers I write?
3.
Still 3, right? Okay, so you can see what we can do is we can find a way to map the 88 to 1. How we can converting the 88 to 1? Anybody can tell me about this? How we can converting the 88 to 1?
Subtract 87.
87.
Subtract 87, right? Okay,
Yeah.
how we can converting 89 to 2?
Subtract 87.
How can I converting 90 to 3?
Subtract 87.
Okay, so you can see by subtracting 87, we converting the counting problem of 88, 89, 90, how many numbers here, to by counting 1, 2, 3. Because you know, for 1, 2, 3, it's very easy to understand, okay? Because if I write 1, 2, 3, 4, 5, that's 5 numbers. If I write 1, 2, 3, that's 3 numbers. If I write 1, 2, 3, 4, right, that's 4 numbers. Okay, is that true? Okay, if you kind of understand this concept, my question now is because see we write the 66 and the 78, right? So how many numbers from 66 to 78? How do we use the one-to-one correspondence to counting?
Subtract 16.
How much we should subtract? Think about it.
65. 65.
65.
Yes, we subtract 65. Is the first number 66 mapped to 1, right? And the 78 mapped to what?
Minus 65. Minus 65 is
13.
Is 13, right? So
if
if
13 here.
okay, if you feel hard, you cannot counting in this domain. You can do one-to-one correspondence counting in this domain. Okay, in the mathematics, we call this approach is one-to-one correspondence, or we call the bijection.
What is a minus 65?
Okay, so how many numbers from 66 to 78?
how many?
66 from 68. That's hard.
How many?
That means here 13.
Yes, we have 13 numbers from 66 to 78, right? Okay, so you already know these 13 numbers you are going to fill in. Do you agree with me?
Yeah.
Any questions so far? Or any problems I can explain. If you have any problem, let me know.
Mommy, please.
Okay, if you don't have any problems, then my question is how many numbers we are going to fill in? We already calculate, right?
3, 4, 5, 6, 13. 11.
How many spacings here, including the number it gives to you?
14.
14. You already know which 13 number to fill in. How many number left? What's the uncertainties for you? Who tell me what is uncertainties? So which number you think? Okay, you don't know. You need to add to fill in this diagram. Is this either 65 or what?
Or it can be 79.
9.
Or 79, right? Because I have 13 numbers here, I'm only missing one numbers, and they need to be consecutive. So I either need to fill in the 65 or I need to fill in the 79. Any questions so far?
I think I have a question.
Sure.
I think I don't really know. I think.
You don't really know your question is?
Huh?
You don't know what?
What is the question?
Academy.
Oh, you don't really know what is Beast Academy?
I just know it.
What you don't know? Okay.
Are you okay with anything I talk about so far?
Yeah.
Okay, I talk about the one-to-one correspondence, right? I talk about how to counting. If you feel from the 66 to 78, you don't know how to count how many numbers there. I teach you guys the one-to-one correspondence, right? Called the bijection. So you can converting the 66 to 78, right? To a range. It's very simple from the 1 to 13. They have the same number of numbers, right? Okay, if you understand this one-to-one correspondence, how we count, right? To make it to convert in some domain, you think it's hard to count, to some domain it's easy to count, right? Okay, so now we already know we either have a 65 or 79, right? We don't know. Now let me guide you, okay, to see, do you think how can we figure it out? Okay, we need to add 65 or 79. Okay, who can tell me which number I should put here?
67.
67.
67, right? Okay, now let's think. Let's think. Okay, if okay, you can think. Is this 66, 67, 68? Right? So 69 can be here, 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 right? Is that true?
Yes.
Okay, if I have a 79, the 79 could be somewhere here, right? Because the 79 need to be next to what?
78.
Think about it. 79 need to be next to 78. That's here, right? So then what the problem of this cell? Is this cell become isolated? What I mean, okay, let me repeat what I'm saying. So if I assume, okay, the smallest number, if we need to add the 79, right? So the 79 can go here, can go here, can go here, and can go here. Do you agree with me?
Yeah.
Okay.
Yeah.
Then 69 can go here, right? Can go this all these positions. Is this the 69 can go? So this cell will be isolated. Did you see it? You cannot fill in any number here now because you are not allowed to go here then go back, right? Because the number need to be consecutive. Once you do the path, the number should be increased by 1. Okay, so if you fill 69 here, right? You fill 79 some here. This number, you don't have any number to fill in. Any questions on this analysis?
No.
Okay,
No.
so what does this mean? This means which number we should add, either 65 or 79. based on our analysis?
65. Why?
Yeah, we need to add a 65, right? We already eliminating the reason I already gave to you. We need to eliminating the 79, right? So now you know this is not possible. So the only possible way is 65. Okay, so I think up to here, even I don't need to fill in the numbers. Okay, so what I'm doing is first you can think. Okay, for this puzzle, the logic thinking is the invariant.
Why is there an X there?
Shh. It means it doesn't work.
Okay, the invariant is the number of the cells in this picture. The number of the cells determines the number of the consecutive integers you need to fill, right? You know you need to fill 14 consecutive integers, right? Then the rest of them is based on the number it gives to you, right? You list what is the smallest number is, and you list what is the largest number is. Okay, then you can fill, or you know how many numbers are already deterministic, need to be filled in these structures. Okay, so this is then we have to be involved with the counting problem. Is from 66 to 78 is how many positive integers there. If you feel it's hard to counting from the 60 to 66 to 78, how many positive integers here, right? So we introduce a one-to-one correspondence. The one-to-one correspondence means, okay, for a range, you think it's hard to count how many numbers here. We're converting them into a range. We are easily understand how to count here. Normally, very easy is we know a consecutive number is starting from 1, right? 1, 2, there are 2 numbers. 1, 2, 3, there are how many numbers?
3.
3. 1, 2, 1, 2, 3, 4, how many numbers?
It needs a pen.
Yeah, 4 numbers. So now let's converting the smallest number to which one? If you have a range, consecutive numbers, you want to counting how many numbers here? You want to convert the smallest number to what?
What?
1. Yes. How we can convert 88 to 1?
Minus 87.
Minus 87. Now we do the same thing for the last number. What is 92 minus 87?
5.
5. So this means the number of numbers here is equivalently of number of numbers 1, 2, 3, 4, 5. Is 1, 2, 3, 4, 5 is an easy job for you guys? I think so, right?
Yeah.
Okay. Now you can solve how many numbers between the 66 and the 78. Right? So this gives you 13 numbers. This is guaranteed. So you guaranteed you need to fill in these 13 numbers, right? And you totally need to fill 14. So you're missing one number. Because they are consecutive, so their missing number is either 65 or your missing number is either 65 or what? Can anybody help me?
50.
You're missing one number, right? You can minus 1 here, go smaller here to 65, or you can go
75.
you can go one bigger here, right? To 79. Did you see it? Did you see it?
78.
Okay, so you either add a 65 or add a one of the 79 to fill in here, right? Okay, now let's see, because we have to make a decision, either 65 or 79, right? So the next step is we want to see which one can fill in the 79, right? So 79 must be what? Must be next to
78.
what?
78.
78. So 79 must be next to 78, so you can fill in here, 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 right? And this is the 67, right? So this is the 69, right? Okay, if you know your number is from 66, 67, 68, 69, then you can go 70, 71. That leave this cell become what? If you are doing 79, make this one to be
Empty.
isolated, right? This is not allowed. So that's why, based on our analysis, 79 is what? Possible or not possible?
Not possible.
Not possible.
Oh, okay, 79 is not possible, right? Now we can see, we can fill in, let me fill it in for you. 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, up to 79. Because 79 is not possible, you know all the numbers you need to fill in is from 65 to 78. Okay, so you can see the approach I use, okay, or the approach, basically the logic thinking, the mathematics logic thinking, okay. We try to train the students not to avoid all this random try. Just fill in 67 here, fill in 65 or 67 here. We try to avoid all the random try approach. We use the logical thinking. Okay, to determine as much as we can and make the rest of them is easy. Okay, so this one we call the sure way bashing. Okay, this one we call the sure way bashing, or you can call it direction guided bashing. Okay, so sure way bashing or direction guided bashing means if I fill in these 14 numbers, okay, I didn't just call random try. I follow all the structures. I know what is the range, what is the smallest number, what is the biggest number. And based on the number I have is 68, 66, and 78. And I know how I can fill in all these numbers. So that's the recap of this problem. Any questions?
No.
Okay, if no question, we can try another one. Okay, very, very similar. Very, very similar. Okay, so the first, okay, what are we going to do? What's the first step? Based on the last problem, what is the invariant? What is the invariant for this puzzle?
3, 4, 5, 6, 7, 8, 9, 10, 11.
Good. So we have how many number of cells, right? How can we counting the how many number of cells here? We can divide into
No.
rows, right? 2, R3, R4, right? How many cells in the R1?
3.
How many cells in the R2?
4.
4. How many cells in the R3?
Next one.
4.
How many cells in the last row?
8.
How many in total?
11. 14.
Who can add them together?
14.
14. This 14 means what? I needed to have 14 numbers here, right? Okay, then we see, based on the number you see, which is the smallest number?
102.
102.
Which is the biggest number?
102. 115.
Okay,
115.
my next question is between 102 to 115, how many numbers are there? How do we converting? One-to-one correspondence, right? How do we do that? How do we do this one-to-one correspondence? We want to converting 102 to which number?
To 1.
What?
To 1, right? So how can we converting 102 to 1?
You take how many?
Take out 101. Do you agree with me?
101.
Yes. Then 115 becomes what?
100.
This is a one-to-one correspondence, right?
How many do you have left?
Yeah.
Is who can tell me what is the 115 minus 101?
It equals
14.
Equals 14. Who can tell me how many numbers from 1 to 14? We have 14 numbers. Then who can tell me how many numbers between the 102 and the 115? 14 numbers. Okay. So we need to fill in 14 numbers. And based on the smallest number and the biggest number, we already have 14 numbers. So do we already know which number we need to fill in? Must be 102. Yes or no?
No.
No.
Yes.
Yes.
Yes or no?
Yes.
103, 104, up to 114 and 115, right? 115. So that's all the numbers we need to fill in, right?
Yeah.
Okay, so what's the next step? So you can see it gives you 102 and 104, right? So where should we fill in 103? Between
In the middle.
in the
In
middle.
the middle of the floor. Yeah.
Okay, now let's see. You have the 113 and 115, right? Which is the possible way for us to fill in the 114? Let me see. This cell is called A. This cell is called B. We need some logical thinking about either way. We can go either A, 113, 114 to 115, or we can go to the 113, 114 to 115, right?
Yeah.
Okay, let's think. You can think. Normally we want to go 102, 103, 104, then go up to here, right?
Yeah.
If I feel the 114 here, that means I can. If I feel here, I have to go back. Did you see it?
Yeah.
So that means 114 must be in A cell or B cell.
A.
Yeah, so the 114 must be in the A cell, right?
Yeah.
Okay, so I think if for logical reasoning for this puzzle we are done already. This is I still call this, we didn't do random try, okay? We use all the informations possible to make it problem more deterministic. Okay, basically this kind of bashing is the sure way bashing, right? Or either sure way bashing or you have the direction guided. You know which direction to go. You just not randomly fill them up. So you know 114 is here. Now the rest is easy, right? So we must go 105, 106, 107, 108, 109,
110.
113, 14, 15.
Uh-huh.
Right? I mean, my last step is just to help you to fill it out. Okay, fill out the blank. But basically, up to here, we're already done. You know which number to fill in. You know which one is 114. This puzzle you already solved. So, any questions on the hexagon puzzles? Hopefully, you already learned how we do how we counting the number of consecutive numbers by doing the one-to-one correspondence, or we call the bijection here. Okay, this is a very, very important concept. Okay, this bijection not only used for here, this is very simple. Okay, this bijection is also used a lot in the IMO. That's in the National Mathematics Olympiad. Okay, that's the IMO. That's the highest level of the math competition. Always use this approach a lot. Okay, the bijection is a key to converting the some range is hard or some counting problem that is hard to some counting problem that is easy, as long as you see the one-to-one correspondence or the bijection. So I want to ask again any questions. If not, we can move on. Okay, seems no question.
Yeah.
Okay, if no question, okay. So you guys want me to solve the puzzle like a puzzle, or you guys like to solve this inequality sequence puzzle? You know, how we can sequence all the numbers. Which one you prefer for the next one?
Sum 8.
Okay, sum 8. Okay, so this is the double star problem from the BIS Academy. Means it's they think it's pretty hard, right? Because for random try, yes, it is hard. And I also show you guys what in the mathematics, what is the logical thinking? Okay, so how we do the sure way bashing, okay, to solve this problem. So I would just wonder, have you all learned about the even number and odd number?
Yes, even. Even 2, 4, 6, 8, 10.
Okay, so even means there is a pair, right?
Yeah.
Yeah.
Odd means there is a single, right? So I can have multiple pairs, I can have a single ones. That's between the even and odd. So anyone can tell me what is the even number plus even number?
Even number plus even number equals even number.
Okay, how you understand it, I tell you, okay? Because you know, each even is a
2
pair,
plus
right?
2 equals 4.
Each
2
even
plus 2
is a
equals
pair. So basically, if I have a number of pairs, I add another set of number pairs, do I have a single ones?
No.
No single, so it's even. Okay, now let's see, okay? Who can tell me what is the even plus odd?
Even plus odd.
Odd.
Okay, you can think in this way. Even number give you all the pairs, right? But the odd number means I have some pairs, but I have a single, right?
Yeah.
So you can combine all the pairs together, right? And you still have a single ones, right?
Yeah.
So that means even plus odd is equal to odd. Then who can tell me the odd plus odd?
Even.
Even. Even.
Is equal to even, right? So let's see why, okay? So I have some pairs, but I have a single, right? For this one, I also have some pairs, but I also have a single, right? When I combine them, I can combine all the pairs together, right? But I have a single one. Did you see I have a single one from the first odd? And I have a single one from the second odd. I combine them together. This become a single or a pair.
Pair.
It's a pair. So that's why this is even. Okay. So basically, this is all the informations we are going all the I mean the knowledges we are going to use for this problem. Okay. So for this problem we are going to use, you need to know what is even, what is odd. You need to know even plus even is even plus odd is odd plus odd equals even. Okay. Now this problem, let me talk about this problem, okay? This problem is asking you, okay, to, for example, I mean, you can leave some numbers and cross some numbers, okay? So such that the number you left, okay, satisfies every row. For example, if you leave number 4 and 4, you need to take out 8, 8, 8. Because for the first row, the sum need to be 8. Your sum of the number you left on this grid, okay, for each row, it need to be 8.
Oh.
And the number you left here for each column is also need to be 8. Okay, so
What? So hard.
okay, so you can see why the problem is hard, right? Because you have so many possibilities, right? I need the picture to be clean. Okay. Okay, so the problem is hard here because you have so many possibilities, right? So now we need to list all the possibilities, okay? In order to make it become 8, right? So what can we do? 8 can equal to 8 plus 0. Am I right?
Yeah.
Anything else? Take a look at the number it gives to you here, okay? How can we, what's the other possibilities to make it 8?
4 plus 4.
4 plus 4, good. Anything else?
2 plus 2 plus 4.
Okay, so 4 plus 2 plus 2. Anything else?
2 plus 2 plus 2 plus 2.
5 plus
Do you have,
5
yes,
plus 3.
possible, 5 plus 3, but do you have 5 in this grid?
No.
So you don't have to think about it, right? You don't have such numbers. Okay, so now let's see, okay? Let's do the sure way bashing, okay, first.
Done.
Which number is definitely we need to cross out? Think about it.
1.
1. Do you know why? Because all the even number add together must be even, right? You
Yeah.
8 is a what number?
Even.
Even number, so you cannot adding any odd numbers. Okay, no problem. First, good, very good. You guys can see this for the first step. So what is the second step? Okay, let me give you some hint. Okay, so first you can in order to clarify my solution, I want to say this is column 1, column 2, column 3, column 4, and column 5. And I call this row 1, row 2, row 3, row 4, and row 5. Okay, this is the first step. Okay, the second step, let me give you the hint. Okay, so what you can see here, what? I mean, the Google mentioned my Google Meet version is only 1 hour, or maybe yeah. I need to extending this hour this session. At least I need to talk about some of this problem. I need to finish this problem. So the second one you can think. Okay, let's see the column 1. Okay, the column 1. Let's think. If we use all of the 2's, how many 2's we have on the column 1?
How many tools do you have?
How many 2's we have?
3.
3 twos.
3 2's. Let's adding all of 3 2's equal what?
6.
6.
6.
Is this less than 8?
Yeah.
Yeah.
What does this mean? Means if I don't use 4, what could happen? Can it be possible on column 1? If I don't use 4 on the column 1, is it possible?
No.
No, it's not it's impossible. And reversely, it does mean what? We must what?
Use 4.
Use 4 or not use 4?
Use 4.
We
Use
must
4.
use 4, right?
Yeah.
If you look at the structure of R5, what is R5? We must, for the R5, we must what?
Use 4.
Use 4 or not use 4? Think about it. If we don't use 4, what happens on the R5? If the R5 is 2, 2, 2, 4 now, right?
Yeah.
If we didn't use 4, what happens? 2 plus 2 plus 2, the maximum is what?
6.
Is it possible?
No.
So we
No.
must what?
Use the 4.
We must use 4, right?
Yeah.
Okay, now let's see the first row. We already use 4. What does this mean? 4, 4, 8, 8, 8. What does this mean? Can anybody tell me? For the first row, we need the sum to be 8, right? We already use 4. Can we use any 8?
Yes. 1A.
If we use the 8, 4 plus 8 is what?
12.
Is it possible?
No.
So what does this mean?
You can't use 8.
We cannot use any.
8.
Any questions so far?
No.
Okay, and in order to make the first row to be 8, we must use 4. Do you agree with me? I'm sorry. I mean, let me. Can we just? Can you please relog to the Google Meet again, and we can go on to finish this problem, because mine is so far is a free trial Google Meet, so it only limited for an hour. So, but can we relog in to start to? Yeah, use the same link. Okay, let's log back. Thank you. Okay, it still mentioned my call is ended in 4 minutes. No matter. Okay, once we disconnected, let's log back in. Okay. So first, let me make sure you can see my screens. Anybody can either type in the chat or tell me you can see my screens. Oh, anybody either can you tell me you can see my screens?
I can.
Okay,
Yes.
can you hear me?
Yes.
Okay, good.
You.
Okay, now let's move on. Okay, so we know we must including 4, and we must including 4, right? Based on our analysis. Okay. Now let's see the next step. Okay. So can we analyze I'll give you a hint. Next, we are going to work on the R2 and the C4. Can anybody know what is R2 and the C4?
Row 2. Row 2.
Yeah, row 2. We are working on the row 2. Can you see what happens here? Row 2. 2, 4, 4, 4.
2, 4, 4, 4, 8.
Take a look how you can make 8. You need how many 2's to make 8?
4.
4 2's, or at least
At least 2 2's plus a 4.
how many 2's you have now?
1.
That means what?
We need to use the 4.
That means you definitely cannot use the 2 on the R2, and you definitely cannot use the 2 on the C4.
C4, C4, C4.
Any questions?
No.
Okay, so next. Okay, next. Can anybody help me to tell me which row and which column we are going to work on?
We're gonna work
R3.
on row 3.
R3. Okay,
Row 3.
you guys need to know one rules. Okay. The rule we need to work on most deterministic. Most deterministic means the most sure, okay, rows and columns.
Oh.
Okay, the most deterministic means less number or more number, I ask you. In common sense, if you have so many choice, okay, which one is you have the less number give you more choice, or the more numbers give you more choice?
More numbers give you more choice.
You want to have more choice to be more deterministic, or less choice to be more deterministic? For example, if I have too many choice, I have choice A, choice B, choice C, can that be more deterministic against I only have one choice? Which one?对，要开一个新的 meeting。没有，不用开，还是老的继续登录。我知道老的继续登录，还有那个 link， 我跟大家说一下。啊，他不让我用啊，他还要让我再 generate 一个。哎呀，那我就再来一个吧。对啊，我要开一个新的 meeting 啊。OK， 行。听不下去了。啊。
你是从一点 training 都没有，你什么都没教他。或者那点都是我和幼儿园教的，你突然就给他讲这些，你看回答问题多的都是那个 Jasmine， 那个小孩应该挺大了，10多岁。
就把这个题讲完吧。
就是会了还用跟他讲那么多吗？
对啊。
让他们知道是怎么回事。再说你的初衷是给家讲顺带别人。
对啊。
问题是你现在家都不听啊。
那人少就不开了。
不，他们要人多呢，你就开。那等以后佳佳你再给他讲一遍。
行，把这个讲完，讲完就可以了。
Hi.
Hi. Hi. Yeah, let's finish this problem.
Hey, you're not supposed to do that.
Yeah, let's wait for a few minutes and let's finish this problem. Okay. So we can move on. Can anybody see my screens first?
Yes.
Okay.
Yes.
You can hear me okay, right? So now I'm saying we are going to work on R5, right? So the row 5 altogether need to be 8. Then what happened here? Because I mean we are just talking about the rule which how to pick the column or the row to work on the next, right? So what we want to know, the rule is we want to be more deterministic. More deterministic equivalently in this problem here is less choice. Less choice in this problem will be less numbers. Do you agree with me? Any questions on this rule?
No.
No questions, right? So I think the R5, see, it has less choice, right? And less numbers. So if I have 4, I need to add it into the 8. That means I must what? For the R5, I need to be sum of the 8. That means I must pick Any questions? 2 plus 2 plus 4 equal
8.
8.
Really, 8.
Right? Okay.
Yeah.
Now you can see, do we already reduce this problem a lot now? Okay, so you can think about this one, right? Can you think about the first column?
The first column, we can do 2 plus 2 plus 4.
We must including 2 and 2, right?
Yeah.
Okay, for the fourth rows, what the number we are missing?
We're missing a 2.
We are missing a 2 means 4 is not possible, right?
Yeah.
Then for this C4, you need to be 8.
No, 4 plus 4.
You must include 4 and 4, right? Okay, then for R3, you need to be 8. What's the choice? Four plus 2.
Plus 2.
Can you have this 4?
No.
No, okay. Then for C3,
We only need 4 plus 2.
4 plus 2.
4.
If you pick this 4 and the 4, you cannot pick this 4, right?
Yeah.
Then R4 is 2 plus 2 plus 4. You cannot leave this 2, right?
Yeah.
Do we solve the puzzle?
Yeah.
This is called the sure-way bashing. This is I call the sure-way bashing to solve all the BIS Academy double star problem. So you can see, okay, the BIS Academy is really testing you with the logical thinking. So the one, okay, that you can use the random try to solve this problem, but once the possibility become very big, okay, and if you don't solve it systematically, then you didn't apply any logical thinking. It's very time consuming. Take a lot of time, and you may not solve it. Okay, so what I show you is what is the systematic bashing approach. Okay, how do we use the logical thinkings to do the sure way bashing, or to do the direction guided bashing, and all this concept will not only use in the BIS Academy level. All this concept you can apply them to harder and harder problems, even to the AMC 10, AMC 12. That's the American High School Math Competitions. And then you can also apply them to the AMI, the invitational math exams, math competitions. Then from then on, even the Math Olympiad problems. So yeah, since I already extend more than 1 hour, and I want to finish up to here. So today we talk about 3 problems, right? Let me recap. So the first is we want to fill in the numbers that consecutive, right? And the consecutive numbers need to be next to each other on the hexagon grid. And we want to find the invariant of this structure, right? Is the number of numbers. So from this number of numbers, I think you guys better to learn how do we count how many numbers in a range, right? Then we have the one-to-one correspondence. Okay, that's what we did here, for easy for you to understand instead of just remember some formula. Then we can fill them in, right? And we reduce the possibility to we don't know, either we have the one number to the left or one number to the right, and then we can, based on the structure, to analyze which one is the case. So for the second problem, it's the same thing. So we repeat the process we just did for the first problem. Okay, and we also analyze the structures. We counting how many consecutive numbers on this grid, and we do that. And for the last problem, we did the sum 8, right? So instead of the randomly try, okay, for the first row I want to pick this 8, I want to pick this 8, I want to pick this 8, I want to pick the 2 4s. Then you have 1, 2, 3, 4 choice, and you don't know which choice right? So we want to, instead of doing that way, we want to do logical reasoning. So based on our even odd numbers, we know all the numbers are even and 8 is even, so we know 1 is not possible, right? Then we're starting with the first column and the last row, right? So what we are thinking is the reverse thinking. If we don't have this 4, right? If we don't have this 4, then we only have 2 plus 2 plus 2. That's only 6. This makes it impossible. Okay, makes it impossible. So that's why inversely we must including this 4 and must including this 4. Now the next is, if we including the 4 on the R1 and including the 4 on the C5, we cannot including any 8, right? So you can see we just like a peel of the onion. We peel one layer and against peel another layer and against peel another layer until the problem becomes more and more and more deterministic. This is called the short-wave bashing, and you can see how powerful it is when we solve the BIS Academy problem, and you will also see how powerful it is when we solve the Math Olympic problems. So yes, and with that, I think if I already, over 15 minutes, I want to see, is there any questions for these problems? Is there any questions for the problems, or is there any comments on the systematic approach I'm going to teaching?
No.
Yeah, or anyone, maybe your parents, if your parents have some questions to ask me about the systematic approach I'm going to teach for this the BIS Academy, okay, you can also feel free to ask. What I can tell you is the free and the trial and the systematic solutions is totally two levels of the mathematical thinking, of the mathematical logical reasoning. Okay, it's way different. I mean, the systematic approach is much more powerful and more mathematical ways. This is with better starting training from the little kids. And what I want to do is I want to make it simpler. Okay, I want to like show you the one-to-one correspondence. How do we count? I make it very simple. I make it you can see the relationship between them, so you fully understand. Once you fully understand, you can do it by yourself. So any questions? If no question, let me see. One time, twice, 3 times. Okay, if you don't have any question, then I thank you for your participating on these lectures, and I wish you all guys have a good long weekend and enjoy the night. Thank you. Bye bye.
Thank you.
Oh, yes.
没有问题，就是说声谢谢。
好好好，没有问题。好，那就这样，拜拜啊。
好，拜拜。